1, we are told that the measure of angle AYX, this angle right over here, is equal to the measure of angle B. So when we are figuring out which statement is not true, we need to keep in mind what corresponds on these two similar triangles. The reason I know these triangles are similar is because they have a pair of congruent angles, small triangle, large triangle, and they also share angle A. I'm also going to just redraw the triangles so I can put their corresponding parts together. So I'll start with the large one, I guess. A, B, C. A is congruent in the small and big triangle because it's shared, so it needs to go in the same spot. And this angle is the same as this angle. So if this angle's over here, I'm going to put this angle in the same spot. Oh, sorry, I messed that up. This angle's on the left, so I'm going to put this angle on the left. So if you don't redraw the triangles, it might be hard to see what's going on, and you might end up choosing the incorrect answer choice. So let's take a look. In the first one, it has AX. That is from the small triangle. AC, that corresponds from the big triangle. So far, so good. Over here, we have XY from the small triangle, and that corresponds to CB from the big triangle. All good. Small over big, everything's corresponding. Answer choice number 2. AY from the small triangle, that corresponds to AB from the big triangle. AX from the small triangle, and that does correspond to AC from the big triangle. So that's good. That's set up correctly. For number 3, I'm going to actually write the proportion that would lead to this product. So that would be AY over AB equals to XY over CB. And then we can check that out. AY is from the small triangle. AB corresponds to it from the big triangle. XY is from the small triangle. And that does correspond to CB. So that's good as well. Let's check out answer choice number 4, which must be our answer. The proportion that leads to that product is AY over AX equals to AC over AB. If you cross multiply, you get that product. AY is from small. AX is also from small. We just need to make sure this is big over big and that they correspond. So does AY correspond to AC? No. AY corresponds to AB. So answer choice 4 is the choice we're looking for. In question number 2, we're given that these points are midpoints. So what we have here are mid-segments of the triangles. And we know that the mid-segment of a triangle is parallel to the third side, the side it's not touching, and it's also half the length of the third side. We're told here that AC is 10. So I don't know if it's going to help me, but if AC is 10, that's the base, the third side for this mid-segment, because this mid-segment's not touching the side. So this mid-segment is 5. AT is 18. So that's the third side for this mid-segment because it's not touching this mid-segment. So this mid-segment over here would be 9. And CT is 22. which means this midsegment would be 11. We need the perimeter of parallelogram CDOG. Okay, so some of the stuff here is helpful. The 11 and the 5. The other stuff wasn't necessary. Opposite sides of a parallelogram are congruent. We also know this is 10. This is a midpoint. So 5, this is 22. This is a midpoint. So 11 and 11. So we have 11 plus 11 plus 5 plus 5. That is 22 plus 10, which is 32. In the next question, we have triangle ABC dilated by a scale factor of 3. So just as an example, I'll just draw you a picture really quickly. So let's say those are the sides of one triangle. These would be the sides of the other by a scale factor of 3. And it's asking which is true about the image. This first one says, if you take the image and you triple it, you get the original. That's not true. If you take the original and you triple it, then you get the dilated one. So this one's backwards. This next one is saying that the length of the image after the dilation is triple the original. That's true. You do take the original and multiply it by 3 to get the new one. In number 3, it says the angle after the dilation is 3 times the original angle. The number 4 is saying something similar, except the reverse. Both of these are not true because dilations create congruent corresponding angles. So before and after a dilation, the angle measurements will stay the same. The sidelines change, but the angle measurements would stay the same, and that's going to be very important for the test. This next one over here is challenging because the triangles are drawn in a way that is confusing. Here, we're not given that any angles are congruent, but we have the names of the triangles that we can use to redraw the triangles. So that'll be my big one, my small one. So I have triangle ABE and triangle ADC. Now let's label 5.6, 4.1. 9.02, 12.32. And we do have angle A shared between the two. And when you redraw the triangles, now what we can see is that we do have some corresponding sides here. Now we have to check if they're proportional. So I'm going to make a proportion involving the corresponding sides. Oh, my bad. I wrote AC for AD. AC is 12.32. And I put AE over here on BE. AE is 5.6. Much better. And if the corresponding sides are proportional, then I'll have SAS. Those correspond. Those correspond. Let me cross multiply and solve. And now I'll cross multiply the other way, and I'll see if it's equal. It does not end up being equal. No, the triangles are not equal. For your explanation, you can say corresponding sides are not proportional. Instead of setting up a proportion, you could have also found the scale factors. For this one over here on the left, question number 5, we're told that angle H is congruent to angle RDO. We also have a shared angle between the small and the big triangles, and that's angle R. So the triangles are similar by AA, so we can make a proportion. The thing is, it's hard to make a proportion when you don't know what corresponds. If I label the triangle, I can try to see what matches up, but it's hard to see. So I'm going to redraw the triangles, and I'm going to make them face the same way. I'll keep the big one as CHR. They share angle R, so on the small one, I'm going to put angle R in the same spot. And these two angles are congruent, so they have to match up. So if angle H is over here, I'm going to put angle D here, and that leaves O for the top. Now I'll relabel the triangles. RO is 6. RD is 4. I need to find CD, but CD is not part of either triangle. So what if I find CR instead? And then once I have CR, I can subtract 4 to get CD. And over here, RH is 10. Once you have the triangles redrawn, it's much easier to see what you need to use in your proportion. So I'll just do 6 over x, those correspond, and 4 over 10. I have 60 is equal to 4x. So x is equal to 15. Okay, moving on to the next one. This is a dilation. When we're describing a dilation, we need the scale factor and we need the center. For the scale factor, I'll use the easy sides 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. So I'll do 15 over 6 to get the scale factor. Yeah, it says A prime, B prime, C prime is the image. So we're getting bigger here. So let me divide. That is 2.5. So dilation scale factor of 2.5. And now we just need the center of dilation. I'm going to just draw a line connecting the image, pre-image point. And remember the center should be on that line. I'll do the same thing here. Image, pre-image. The center should be along that line. Sorry, it moved a little bit. Oops. Okay. And last, image, pre-image. center should be around that line. I don't know if you see it keeps moving after I place it down. So that'll be a little bit more accurate if you're using a straight edge and paper. But the center, the origin, I should say, is where they all intersect. Center at the origin. In this question, we're writing a proof. So we need to prove a product. So we have 3 steps. Prove triangle similar, prove a proportion, and then prove a product. I'm going to use the proof statement to figure out which triangles I'm proving similar. AF, EF, DF, so one triangle, BF. I know I'm looking for AA, and I already see the vertical angles. I also see alternate interior angles because I do see a letter Z. Now, in order for alternate interior angles to be congruent like we want them to be, we need parallel lines. Let's think about if there's any way we can get those lines parallel. In the givens, it does say ABCD is a parallelogram. So that's where we can get these parallel sides from. And then we're basically all done. So we have parallelogram ABCD that was given to us. So AB is parallel to CD. Opposite sides of a parallelogram are parallel. And from there, we can say angle A is congruent to angle FDE because alternate interior angles are congruent when parallel lines are cut by a transversal. Then I can say angle BFA is congruent to angle DFE. 1, 2, 3. This is 4. Sorry about that. And that's because intersecting lines form congruent vertical angles. So that's everything we need to say triangle ABF is similar to triangle DEF. Don't write congruent, write similar. And that's due to AA. I'm going to continue over here. Now I proved my triangle similar. Now I need to prove a proportion. So I'm going to take the segments from my proof statement and I'm going to put them in a proportion. Just make sure that you double check and you cross multiply, that you make sure when you cross multiply, it gives you the proof statement, AF times EF DF times BF. If it doesn't, you'll have to rearrange. When you're proving a proportion, it's the same reason every time. Corresponding sides of similar triangles are proportional. When you're proving a product, it's the same reason every time. In a proportion, the product of the means equals the product of the extremes. In this question, we have a situation where we have a big right triangle with an altitude drawn to its hypotenuse, creating two smaller right triangles. So it says that the length of AD is 6, that's already labeled, and the length of DL is 4 times the length of BD. So I don't know either of those, so I'll represent BD with an X, or you can call it, yeah, X, because I don't know what it is. DL is 4 times the length of BD, so I'm going to represent that as 4X. Now, I'm going to redraw the 3 triangles so that they're facing the same way, and that way I can easily make a proportion. So in the big triangle, the right angle is at A, and I'll just write L and B. Those don't matter. We're just going to label the other two based off of that. In both of the small right triangles, the right angle is at D. And now we're going to think about what each of the small triangles shares with the big triangle. We'll start with the medium triangle. The medium triangle shares L. L is in this triangle, and at the same time, it's also in the big triangle. So if I put L here, I'm going to put L here in that triangle, and that leaves A in this triangle to be the last letter. In the small triangle, B is shared with the large triangle. It's in the small triangle, and at the same time, it's in the large triangle. So if B is here, B needs to be here, and that leaves A. Now I'll transfer the numbers. AD is 6, AD, AD. BD was X, DL is 4X. And I have everything I need to make a proportion. These are the 2 triangles that I have information about. But remember, all these triangles are similar. Anytime you have a big right triangle with an altitude forming 2 smaller right triangles, they are similar to each other. So I can make a proportion. I'll do 4x over 6, those correspond, and I'll do 6 over x. 4x squared is equal to 36 divided by 4. X squared is 9, square root, x is 3. So BD is 3, because that is x. In number 9, it's saying which similarity statement is correct. Based on the information, it looks like it might be SAS, or it could always be none. So let's check it out. I do need to see what corresponds. So I'm going to just redraw the triangles. For me, it makes it easier. So I'll keep this one SGR. This corresponds, so I'm going to put R over here. A and G correspond, and that leaves T for over here. So GR is 36, SR is 45, AR is 15, 18. It's just helpful for me to redraw it in this question. So I'm going to do 36 over 15. Those correspond 45 over 18. I'm going to take a moment and cross multiply. 36 times 18. That is 648. 15 times 15 is 225. These are not similar. The sides are not proportional. Okay. The first thing I have to do here is take the equation that was given and solve it for y. So I'm going to subtract 4x. And divide everything by 3. Now I have it solved for y. So I'm going to take a moment and graph. The y-intercept is 8. 1, 2, 3, 4, 5, 6, 7, 8. The slope Tells me I'm going to move down 4, right 3. And we're dilating by a scale factor of 2, centered at the point 34. Here's the center. Notice that the center is on the line. So when the center of dilation is actually on the line, remember all the points are going to shift along the same line. So it's going to result in the same line as we started with. So Aaliyah is not correct. The equation of this line after the dilation is still going to be y equals negative 4 over 3x plus 8. For the second part, it says describe how the question can be changed, so she's correct. If the question said that the center was at 0, 0 instead of 3, 4, then Aaliyah would be correct, because if we're centered at the origin, remember slopes stay the same before and after a dilation because dilations make parallel lines, but the rule for the y-intercept when you have a dilation of a line centered at the origin is that you multiply the y-intercept by the scale factor. And that's what Aaliyah did. Aaliyah multiplied the y-intercept by the scale factor to get 16. So that only happens when you are centered at the origin. But here we're centered on the line, so it's going to result in the same line as the original. So no, Aaliyah is not correct. No, since the center of dilation is on the line, it will result in the same line as the original. Here we are just proving two triangles similar, so we know that's going to be done through AA. We're looking for angles. One of the triangles is ABC. Sorry, this is supposed to be a B over here. So the whole big triangle ABC. The other triangle is BDC. So in the big triangle, we have a right angle. So if we could get a right angle in the small triangle, that would be helpful. So luckily, we know that BD is an altitude, and altitude is a perpendicular line, so it does create a right angle. So already we have a pair of congruent right angles. Now, the small triangles and the big triangle. So we're going to look for a shared angle. Angle C is in the small triangle and at the same time in the big triangle. So there we have it. All we need to do is write up our proof. And we were using this idea in order to set up the proportions with the three similar right triangles and to redraw them, that the triangles were in fact similar. Sorry for my terrible handwriting with the givens. Okay, so I'm going to start with this right angle. So BD is an altitude, so I'm going to write BD is perpendicular to DC, and altitude is a perpendicular line in a triangle. So now that I know that BD and DC are perpendicular, I can say angle BDC is a right angle, and that's because perpendicular lines form right angles. So now I can say angle B, the right angle in the big triangle, is congruent to right angle BDC, and that is because all right angles are congruent. Now I can say angle C is congruent to angle C. That's due to the reflexive property. And that's my two angles needed to prove the triangles are similar by AA. So since we know that D and E are midpoints, we know that DE is a midsegment of the triangle. So I know that it's parallel to the base. Since these are parallel, corresponding angles are congruent, and they also share angle A. So already I see that the triangles are similar due to AA similarity. There is no answer choice that says one only. So one of the other ones has to be correct as well, or maybe even both. So let's check it out. Since these are midpoints, splits that side equally. Since this is a midpoint, splits this side equally. So the sides here are proportional to each other. So we do have side, angle, side. The last thing we have to do is we need to check if the last two sides are proportional. And also, let's give some numbers to see what's going on. I'm just making up a number. Let's say this is 3. This is 3. This is 6. Let's say this is 4. This is 4. This is 8. Already you can see that there's a scale factor of 2. And since this is a midsegment, not only is a midsegment parallel to the base, it's half the length of the base. So for example, if this is 5, this has to be 10. So scale factors of 2 all around here. So SSS also does apply because we do have a mid segment, which is half the length of the base. So once again, it is going to be a scale factor of 2, just like the other sides. In a rhombus, parallelogram properties apply, so the diagonals bisect each other. So if this diagonal PR is 16, it's split equally in half. And if this diagonal QS is 30, split equally in half. A property of a rhombus is that diagonals are perpendicular. So where they intersect, we have right angles. So we have 4 right triangles. They're all the same. Let's consider one of those right triangles. We have 2 sides, and we need to find the third side. So we can use the Pythagorean theorem in order to do that. Remember, in the Pythagorean theorem, C is the hypotenuse. The hypotenuse is always across from the 90-degree angle. We don't know what that is. We are solving for it. So when I plug into the Pythagorean theorem, I don't know what C is, so I'm not going to plug anything in there. I'm going to plug 8 and 15 in. It doesn't matter the order. 8 squared is 64. 15 squared is 225. That is 289. And that is 17. So one side is 17. A rhombus is equilateral, so that means all the sides are 17. So if I do 17 times 4, I get the perimeter of the entire rhombus.